Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 1 in the XXE injection module titled Exploiting XXE Using External Entities to Retrieve Files. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all labs, do a search on XXE injection, and select lab number 1 titled Exploiting XXE Using External Entities to Retrieve Files. Alright, let's get started. This lab has a check stock feature that parses XML input and returns any unexpected values in the response. To solve the lab, inject an XML external entity to retrieve the contents of the XXE passwd file. Alright, so the target goal over here is to exploit the XXE injection in the check stock feature and retrieve the contents of the passwd file. Let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are being passed in my Burp proxy. I am using the professional version of Burp, however, we won't be using any professional features, and so everything that I do in the professional version, you should be able to also do in the community version. Okay, so let's go to HTTP history, click on view details, and look for parameters that talk to the backend. So let's go down, click on check stock, and see the parameters that are in the post request. Let's send this to repeater. Alright, so it's a post request to the /product/stock endpoint. And if we go down right over here, you could see that as a parameter in the post request, it takes in a bunch of XML. So whenever you see XML being processed in the application, you definitely need to test for XXE injection. And that's exactly what we're going to do over here. Now, it seems like it takes in raw XML, and if there is no verification whatsoever on the backend on what XML can be included, then we could read arbitrary files on the system and potentially gain remote code execution. So what we're going to do is we're going to use an external entity in order to retrieve files. So that would be doc type, and this could be named anything. So let's just say test. And then we're going to say entity. And again, this could be named anything. This is just a reference to the entity or the name of the entity. And then we're going to say system, file. So we're referencing a local file on the file server. And the one we're referencing is the XXE passwd file. And if you don't understand what any of this means, that's okay. Just go and watch the theory video for XXE injection so that you could understand the technical details behind the vulnerability. Alright, so what's left to do is just simply reference the XML external entity. So if we go back to proxy and we look at the response of the request, it looks like over here that it takes in the product ID and the store ID. And what happens in the backend is that it searches for the product ID that is available at this store ID, and then it outputs the number of items that are in stock. And so what we're going to do is instead of giving it a product ID of 1, we're going to reference our external entity. And the way to do that is and XXE and then a semicolon. And now if there's no validation whatsoever in the backend and it outputs the raw response of this request over here, then we should get the content of the etc passwd file. So let's hit send. And here we go. So it says invalid product ID because this was clearly an invalid product ID, but it also outputs the content of the passwd file. So if we go back over here, it should say, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability manually. Now let's script it in Python. As usual, the first thing we're going to do is import the libraries that we need. So the request library, the sys library, the URL lib3 library, and then we're going to disable insecure request warnings. So URL lib3 dot exceptions dot insecure request warning. And then we're going to set our proxy settings. So we're sending all HTTP traffic to the location HTTP 127.0.0.1 port 8080. That's where burp is running. Same goes for HTTPS traffic. We're sending all that traffic to HTTP 127.0.0.1 port 8080. All right, this looks good. Next, we need to call our main method. So if name is equal to main, then call the main method, and we'll define it right over here. So as usual, if the length of the command line arguments is not equal to 2, then print the usage instructions, which is the name of the program, and then a URL. And the name of the program we take from the command line argument. So sys.argv 0. And then we're also printing the example instructions, which is also the name of the program. And then just a sample URL, let's say www.example.com. And the name of the program we take from the command line argument. All right, this looks good. Next, we exit the program because the user ran it incorrectly. All right, so let's assume the user did run the program correctly. First thing we're going to do is initiate a sessions object. So requests.session. And then we're going to create a URL variable, and that's going to be equal to the second command line argument. And then we're going to call a function called exploit XXE. That takes in the session object and the URL. Of course, this is a custom function that we need to define right over here. So we're going to say def exploit XXE, takes in the session object and the URL. And we'll print exploiting XXE injection. And then we attempt to exploit the XXE injection. So to do that, you need to perform this request over here. So the path to this request is right over here. Let's copy that and create a variable called stock URL, which is the URL of the main application plus the path to the vulnerable function. And then we need another variable called data stock. And that's equal to the XML that will perform our exploit for us. So let's copy all of this. And then let's put it in here. Now we've got new lines, so let's remove the new lines. 2 more, and here we go. This looks good. Next, we just perform the request. So we're going to say r is equal to s.post. We're saying .post because it is a post method right over here. And that takes in the stock URL. We're going to say data is equal to data stock. Verify is equal to false because I don't want to verify TLS certificates. And proxies is equal to proxies because I want my request to be sent to burp. And then I'm going to print the following is the content of the etc passwd file. And we'll print the response of the request, which will print this entire thing over here. So all of this, including the invalid product ID, but it'll also dump the content of the passwd file. All right, this looks good. It's a pretty simple script. Let's save it. Okay. Now let's go back to our lab and see if it timed out, and it did. So let's open a new instance of the lab. And while that's opening, we go to terminal, new terminal, Python 3, XXE injection lab 01, and then the URL of the application. Let's paste it in here. remove the trailing slash and hit enter, and hopefully we don't have errors. And here we go. So you could see over here, it dumped the content of the past WD file, and you have a message saying, congratulations, you solved the lab. Alright, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at another case of an XXE injection.